Hi, my name is Michael Samarin. I'm with Futurize, and if you are in the Microsoft ecosystem, please do not confuse with the Xamarin. So I get that a lot. And when we were discussing the topic for the presentation, what we wanted to do is to give you a little bit of the inspiration for your everyday business. And we are talking today about the DevOps data in AI, but not in a buzzwordy way. We really want to show you with the very few examples from our client cases where teeny tiny changes of adopting some of the practices and organizational change, you can do great things step by step. And it's essentially up to you how you are going to adopt all the new technologies. And there is so much. But before, I would like to talk about one history lesson. And there will be two history lessons today. And the first one is, please remember, regardless of what we are talking about, there is no silver bullet. And if you take a look at the history, Computer Magazine, April 1987, where Fred Brooks published one of the probably most known articles in the history of computer science publications, titled No Silver Bullet. He also wrote Mythical Man Months, but the second title is The Essence and Accidents of Software Development. And despite the fact that this article is more than 30 years old, it's been challenged multiple times, but the core of the article, at least in my opinion, remains exactly the same. The software is incredibly complex, and the complexity that we have to deal with within a software domain is the essence of software development. And why it's so complex? Because software is essentially abstract of our mind, and we have to bridge the gap between the digital domain and the human domain, and software doesn't exist in isolation, especially in the modern world where the software is essentially part of the society fabric. And simple problems require simple solutions, and the complex problems require complex solutions. When we are trying to adopt the technology, we have to remember that. And in these two sides of the picture, essentially it's exactly the same thing. We are hitting one thing with another. Hammer and the nail, and the nuclear accelerator where we are hitting the particles with the particle. Exactly the same thing. But the approach is different. And we have a tendency to overcomplicate the simple things and oversimplify the complex things. And it leads to this fact. If you look at the statistics, it's actually horrifying that up to half of our R&D budgets is wasted, and combining with the duplication or the actual physical waste. And at the same time, you have ever-increasing the pressure to go to more technological domains, to start adopting new technologies. Where do you stop? Where do you start decipher what is the buzzword today and where we can start applying those things? And if you look at the news, we are bombarded all the time, there is artificial intelligence, there is a cloud adoption, and all those three things that I'm mentioning today, there is a DevOps, there is a data, and the huge, huge, huge cognitive pressure on us. And today I want to talk about very small three things. And I'll start with the DevOps. And I encourage you, so I assume there are more business people in this room than the technical, right? So the business people. And make an experiment with your teams. Ask your team, choose any buzzword, let's say DevOps, and ask your team, do you know what is DevOps? But make sure that in this team are mostly decision makers or salespeople, essentially not IT. And you will be not surprised to see majority of the hands risen. But then ask the second question. Are your teams actually utilizing DevOps? And then you will see a hesitation. And this hesitation comes from the fact that people actually do not really know if I have the automated pipelines, does it mean that I'm using DevOps? Or is it something bigger? And if you look at the traditional description of what DevOps is, we see essentially the merge of the development and operations. But if you look a little bit beyond that, you will realize that it maps almost one-to-one traditional functional approach to the development and deployment process. We have a functional silos, and we have a process. And what happens next, this very typical situation where we are estimating our success by the time, scope, and a budget. And if it happens, we think, this is great. But what happens next with the majority of the projects which are done in this mode, the teams are essentially packing their suitcases and doing the handover and moving next to the next task, to the next project. This is not DevOps. We have to do better, but we are forgetting that our code becomes a legacy the moment it actually hits production. And that's where the work is actually starting. And we are living in the legacy of the functional silos. If you look at our organization, today we have a very strict separation between the business sides and IT sides, and we have those functional silos. Where it leads to waste, where we have one function, handover, waste. Another function, handover, waste. And there is no continuity between the projects. And the project modes are also the problem because we are working in the project mode, then we are scaling back to the maintenance, we're switching to another project mode, maintenance, and so and so. And these are the typical examples what we have, and I'm sure you recognize those. There is a famous ticket ping pong in the maintenance team. The teams are overloaded under the deadline pressures. We have increased technical debt, and so and so and so. And of course, the people are allocation in too many projects. And when we start to look at the bottom of the problem, we have to change perceiving a software as a product. What we are producing, it's a process. Software is a process, and the organization actually is the problem. And if we look at the traditional way of describing the DevOps, which is true, development and IT operations, but also we are talking about organizational change. Nothing we can call DevOps if we have automated our development pipelines, if we have automated testing, and we can automatically deploy, unless we have inherent organizational change that can support completely different style of operations. I heard once an urban legend about the metro, about subway. In one of the largest cities in the world where metro it's been operating for over 100 years, there was not even a single day where metro or subway was not being maintained. Not even a single day. And imagine if we would apply the same paradigm, which is on a physical world that's supposed to run all the time, if we apply that to our software practices. And then it means that we have to do organizational change, which will allow us and which will allow teams to run multiple tasks in parallel. And the Devops team contains everybody who are responsible, including the business, including the product ownership, including the development, of course, et cetera, et cetera, et cetera. And then we are switching to the most important part, continuous mode, sorry. We have teams who are defining the priorities. We have architecture of our solutions defined as a team, and we have the whole chain of what's supposed to be happening in the modern organization. And I would like to show you one picture from one of our dear clients, Sanoma, where one of our DevOps teams, and we are calling Devops Team, the entire team, is running the operations. Ilta Sanomat is the most visited website in Finland. And this is actual physical counter. It's not a joke. These are real numbers. These are the days since the last outage of the service. And that includes that we do have multiple production deployments per day during all this period. And the next, a bit longer client story that I would like to share, how we are using the completely different approach to what DevOps is not Sanoma, but it's actually Finavia. And I would like to tell you a story how we set up the whole team around several projects. So if you look at the passenger digital experience in Finavia, we have to handle multitude of services. And that means the mobile applications, that means parking reservation system, that means the reservation of the lounges, payment processing, and so on, so on, so. All in all, we are talking about something like 10 different client or customer-facing services. And as you can imagine, if something stops, we have, like last year, I believe there were something like over 20 million passengers that were passing through the Vantaa airport. So how do we set up a team and a processes that would handle all of those and would be working not in a crunch mode all the time, but would be working in a normal working mode? So this is our DevOps team for the Finavia project. And the DevOps team includes developers, a team lead and architect, a business owner and the product owner, designers, service designers. And those circles, those are actually not group of people. That's it. That's entire team. And what is most important, that team is several times a week is co-located with the business owners, so we can work together. Moreover, the team is interviewing the actual passengers on a regular basis all the time, because in the end, it's not about us, how we are doing that. It's about the end user experience. And the team is running something like 10 to 15 projects that we would call, but essentially those are continuing tasks which are running in parallel. And the team is doing all of those that we could have as a functional silos before. Business goals, the design, the development, the maintenance, and infrastructure, all in circle, all the time. And interesting aspect, what we decided to apply to this team is that all the technical team members, they are rotating inside between the different responsibilities all the time. And we have, now listen to this, we have close to 40 microservices that are running continuously and supporting this entire infrastructure. And we don't want to increase of course, we want to increase individual knowledge of the team member, but actually we would like to increase the knowledge of the entire team, that we can, just like with the digital infrastructure, we can have team members who can onboard very easily, offboard very easily, and so on. And in the end, about this project, few technicalities. We're using .NET Core. This is a Microsoft conference, so we're using .NET Core to write those close to 40 microservices. And we created the entire infrastructure in such a way that the moment we have a code merge, within 5 minutes, we have it running in the test environment, so our clients and the product owners can actually experiment with those features. And with the single button, we can do the production deployment and rollback. That's wonderful, but how do we know when something is happening, when the problem is happening? And for that, we are using wonderful, fantastic tools. First of all, we are building everything in Azure pipelines, but the most important, we are using Azure Application Insights. I don't know, who's familiar with Application Insights? Friends, it's magic. The whole reason I'm here, do not suppose to say that this is magic, but this is magic. It's really magic. So we can essentially plug Application Insights to any kind of infrastructure. It supports gazillions of platforms and the programming languages and like everything. It can consume your logs, and you can have the overall picture of what's happening between different services, how your request is passing through. If you have a payment, where does it go? And we got the permission to actually show you some real screenshots. So this is from the actual monitoring solution, which is monitoring live the services. And this is a screenshot where everything is fine, and the request is passing normally. And this is the next picture where we immediately can see that there is a service breakage when we have, for example, payment coming into the system. It goes through the 1-2 second service, and then something is happening, and we can react immediately. And yeah, that's it. Monitoring, continuous operations, and what is most important, in the end, we are not doing it for the sake of doing it, we are doing it for the passengers. This is a passenger's digital experience, and we are always very happy to brag about the fact that the Helsinki Airport and some of the digital services of the Helsinki Airport is essentially a multi-year award winner. So if you are interested in technical details, there is a QR code. We wrote the gigantic article last year about the technicalities, so you are free to take the picture. But then, so that was about like one buzzword, DevOps. We have two more. We have AI and data. So what would be the next one? The next one would be actually AI. And today, if I would ask, I think anybody in this audience, I don't think I would get the same answer, what is AI? And I probably, depending on the situation, I would describing it differently as well. And this is a challenge because if we are trying to apply those to our businesses, what is AI and how where do we apply that? And the interesting fact that there is actual, what we call a CSI syndrome, you know, those TV series about CSI, and it has the two negative effects depending on the person you're talking to. The effect number one is we are giving too much credit to the potential intelligence of the system when we are talking about the machine learning or data science, and at the same time, we are not giving enough credit to the system what actually very simple approach to the data processing or advanced analytics we can get in our day-to-day business processes. And let's do another history lesson. In the normal life, when we are designing some kind of a solution, we can pretty well define the sequence of the steps, how we are making decision in a software. So essentially, we have a condition, and we are checking this condition, and it's like a traditional if, then, and else construction. What happens if we have a lot of data? For example, if we have to deal with the image data or sound or a massive amount of data coming from the sensors of the devices, can you start using the if then else? So how many of those you can humanly create? For example, if we take an image which is like 1,000 by 1,000 pixels, it means that we have 1 million parameters. And that's just like one picture. And how do we even describe what is happening on this picture in order to do, for example, an object detection? We are not talking about person recognition, but just the object detection, that there is a person on this picture. We can't. We can't do that. And the same goes to the audiovisual data. The same goes to the large number of classes of data. And in the 50s and the 60s of last century, of the 20th century, there was a notion, what if we will actually try to train? So because we as humans and like animal kingdom, we are trainable. Is it possible to create essentially a black box, which is some kind of a computing system, which we can essentially train? And by training, it means that if we have a large number of samples, we don't know how we are defining those, where there is a face or not, but we know. So we will show to the system, look, these are the pictures, this is a face, this is a face, this is a face, or this is this person, or whatever. And then the system somehow magically, or we hope by some algorithm, will be able to create what is called, in the scientific term, a feature extraction. So the system would be able to calculate or understand. And at the same time, we can have a so-called feature generalization, meaning that it will be able to recognize not only on those samples that we feed it to the system, but also on something in between. So it can create some kind of a general concept of what is that. How do we do that? That's the problem. And again, in the 50s and 60s, where we've got enough tools and understanding of what is the neuron system is, and how our brain is working, we have noticed that apparently there is some kind of electric signal, and if we take a neuron, it has a multiple incoming connections, and when something is happening, the neuron gets excited and starts to generate signal again. So apparently there is some kind of almost like a Boolean gate logic. It's not that simple, but we think it's there. And if we describe the neuron as the mathematical function that does, for example, just a basic summation, and then we have those inputs, and each input is some kind of a value, and we can have some kind of a coefficient attached to this value, and then once it's reached certain threshold, we can generate that signal. It's so far from the real-world application, so we have to do the next step. And the next step is, of course, to try to connect them. And that's what they did in the 50s and the 60s. They started to create artificial neural networks, which is essentially mathematical abstraction. If we have an input array, we have interconnected elements which are mathematical functions, and depending on certain conditions, we can tweak those parameters. So in the end, the system will produce the result that we want. There's only one problem. In the 60s, they invented algorithm or multiple algorithms how to train such a network, how to twist those parameters, but only with the one layer. And one layer only. We could not invent the way how we can tweak those parameters on multiple layers. And after the initial huge spike of the interest to Frank Rosenblatt's perceptron, where there were even hardware implementations, but then it was mathematically proven that it's impossible with the single layer, where we have only few neurons, even that they have like millions of inputs, it's impossible to do any kind of a nonlinear classification. So, and it led to so-called AI winter, which was started in the 60s with the publication of the super famous book by Marvin Minsky, The Perceptrons, where it was mathematically proven that we have to have multi-layer networks. We don't know how to train them. And that's essentially killed almost all efforts until a few researchers, which when we start dig deeper into the history, apparently in the 60s and the 70s and the 80s, came out with the multiple ways. You probably heard deep learning and the backpropagation, et cetera, multiple ways how we can actually train that. So, success, we can do that. We can have a multiple layers, we can have the artificial neural system, but then we are trying to live in the actual hardware realities of the 80s and the 90s. So I was doing my PhD in neural networks in the 90s, and that's the typical approach. We had the images of 128 by 128 pixels, and we had to train for days such systems. It's not possible. Luckily, we have tremendous advances in the hardware. We can accelerate the training, and then if you look at what's been happening in the past 10 years, that's where we are today. We can use all of that knowledge, we can train the artificial systems, we can create what we call machine learning, and we can decipher, we can classify, we can do all those wonderful things that other companies are doing, and we can try to apply them to our own company. And this is the end of historical lesson. Now let's look at the actual problem. The next problem is, in order to actually practically apply all of that wonderful potential benefits, we need data. We need a lot of it, because we have to actually train and prepare the systems. And now, remember your behavior when you have to make some kind of a business decision which is related to any numerical data. I am sure that you are guilty of this crime. I am definitely sure that I'm guilty of this crime. So sometimes what we do, we would like to look at the very usual instrument, like a spreadsheet, to look at the data, because, I mean, we're making a business decision, so even despite the fact that we have some kind of a data lake that's supposed to produce something, in the end, we are asking our friends, hey, can you give me it in Excel so I can actually understand and calculate? And the problem is that we see clients who are handling projects with the hundreds and hundreds of thousands of euros, which are managed by the Excel, or the decisions are done by the static snapshots of some business or production data, which is converted into the spreadsheets, into the comma-separated value files, which we're supposed to feed into the intellectual systems. This is wrong, because we are doing our personal convenience versus organizational wisdom. And that's where the problem starts. And in order to overcome this problem, what we have actually have data governance, we have to have a data transparency within the organization, we have to do the data accessibility, and the data should be alive. It cannot be in a static snapshots, it cannot be in the bunch of random Excel files. And I have two examples where I will show that even without intelligence, the moment when you actually have a grasp of your active live data, you can make significant changes in your business operations. The first example is Fira, which is construction and technology company. And a very simple question. So we have construction sites. This is actual data. We got permission to show that. This is a difference between two construction sites. And if you look at the red line, this is the profitability of the site across the time. And clearly, we have spikes in profitability and then a drop in profitability from the right side from me. And we do have a steady profitability from the left. Why? Why it's happening? Can we actually predict which site, based on the available data, which site will be profitable and which site will be run properly versus the site which is not? How do we extract? Where do we get this data? We can go and do the questionnaires or look at only the resources. So it has to be something else. And that's come the magic of the proxy data. Apparently, it was possible to analyze the check-ins and check-outs of the workers of the construction site and how much time they're actually spending on the site. And apparently, this is a magical proxy data that shows that if site is not run properly, meaning that there is too much wait for the supplies or inefficient operations, it means that people are checking in and checking out very fast. And at the blue, like those tiny bars, you can actually see how people are staying longer, and that it leads to the proper site running. And if we take the next step, so this is just like on the level of a site, but if we look at the whole construction area on the level of the entire country, for example, and in the end, it is a business. If we can get all of these proxy data, if we can get all kinds of data into the single place where it would be available for making the decisions, then magically we are able to see the other things. We can actually start using, for example, in this case, so-called prefabs, where it's actually much faster to prefabricate certain rooms or elements and bring them to the construction sites. These are actual live dashboards from the FIRA. They are done, this is a Microsoft conference, they are done with the Microsoft Power Apps. These are Power BI. And this is actual one of those control centers when they can see the data and they can react upon that. And the interesting part, so this picture is actually, it's not a construction site, it's a factory which produces those pre-manufacturing blocks. And it leads to the fact that FIRA is actually currently in the pioneering area where they are essentially driving forward the systemic change in the construction. The industry was essentially like a zero growth in terms of the profitability, microscopic margins, and in these conditions they're able to increase the profitability up to 40% just by combining, aggregating, and looking at the data. The next case, so data only, no AI, right? So we have to have a next step, add to a little bit of a smartness. Let's look at the weather. Let's look at the weather in Finland. And this is an article from January. Essentially, this January in Åland Islands, there was, I think, the strongest wind in a recorded history. I think it was 34 meters per second, and the last one in the 70s, 33 meters per second. And we are all observing completely, like I live in Finland for 20 years, this winter is weird for me. So it's crazy. So we do have unstable weather patterns, but even if it would be a very constant weather patterns, whenever we have a very strong wind or a hurricane, it leads to this. We have electricity outages, we have power lines breakage, we have the whole tons of maintenance, and because it's government regulations, how delivery, like the energy delivery companies, how they supposed to, what kind of a quality of service that they say they're supposed to deliver to their clients, it means that in the end, the power delivering companies supposed to compensate all those, not only compensate all those lost hours without electricity, but also there is a very big challenge, how to modernize the entire infrastructure. In Helsinki, majority of the power lines on the ground in the big cities, but if you go to the rural areas, these are all wires. And we can't replace entire country of wiring with the one go. There is a lot of legacy, and it has to be maintained. Whenever hurricane or strong wind blows, that's a disaster. And I would like to share you the story about one of our clients, Elenia, and the project that our Tampere team of FutureWise was building for them. Whenever something is happening, the Elenia has to dispatch the repair team. And when we have a major weather event, there are a massive amount of those, and it means that we cannot have ready teams of maintenance being dispatched in time. And the first challenge is, how do we know where to dispatch and how to do that in time? And before the project started, it was a bunch of Excels and the very few people in the control center that's supposed to make a decision based on those. And the first task was how we can actually aggregate this data, how we can make it live, and how we can build so-called role-based UI, where the Finland would be divided by specific areas with the assigned teams in case of the emergencies, and we can order, sort those based on the severity of the weather storm. That was step number one, to get your data in order so it's accessible, it's visual, and you can act upon that data. But the second step that we were able to do is it possible to predict where we are going to have a power outage, where we can have the power line disruption? And it turns out to be, yes, it's possible. If we know the wind speed, the months, we know the situation in the specific areas, we know the temperature, we have weather forecasts, we can use all of those historical data and we can have a predictive analysis. We can train the system based on the historical data, and we can predict, actually, where in the given conditions of the weather we can have expected breakage. And we can pre-dispatch the teams or notify teams there. And also, we can even create a special multipliers which are not coming from the weather data. For example, if the ground is frozen, trees are less likely to fall. It means that we have to gather and observe this data from the actual locations. Or, for example, if there are leaves on the trees, those are most likely to fall down. And aggregating all of this data in this actionable dashboards, and that's what we did. And today, this is an actual picture that we were able to get permission to share from one of those Elenia control centers, where all of this data is live, and we can see the predictions, and we can pre-dispatch teams, we can notify them in advance, and because we are recording all of this historical data, it means that we can actually train personnel of what we can expect in the given situation. So we can play back the storm situation, and we can see what was the predicted path of events and how did it go in real time. And the range of prediction is anywhere between 3 hours to 2 days. That gives us a lot of time to actually arrange the repairment. And apparently, this approach is also quite pioneering, surprising. So there was even 2 papers published based on the results of this project. One related to how we can efficiently coordinate based on the available data, and another one is actual prediction, how we can predict the power breakages. So that's the second story, where again, we have liberated the data, we exposed it to the operations team, we are able to use this data to train the actual system and produce the actionable results. And the last experiment I would like to share with you is actually a Futurize. In Futurize, well, we are a consultancy. We have almost 600 specialists inside. And it's very natural that we are living in those tiny little bubbles. And if I'm working, for example, in Helsinki, how do I know the knowledge bubble of another person? So I have to go and ask, what do you know? Or we do have our internal systems where people can mark their internal competencies, their skills and knowledge, but those are naturally, we're humans, not always up to date. And then we came up with the idea, what if we aggregate the skills data from our internal system, we aggregate our internal communication channels. Currently it's Slack, it used to be a Flowdoc. And what if we look at the calendar marking data, and can we create those knowledge bubbles that whenever I need something, I can train the system and I can find a specialist. And essentially what I'm doing, I'm breaking the bubble. And so our internal system, a surprise, is called Bubble Buster. So I have actually a recording of how internal system operates. So we can search through the terms, and the system can produce the knowledge bubble. So this is, for example, I type the Azure, and too many people, I would like to narrow it to 10. So, and that's where I can make a decision who I can contact next. Or, for example, let's try another term, for example, DevOps. And moreover, what I can have, we can have the competencies, so who are the specialists from the development, from the business side, or, for example, this is a wonderful example, for example, Tampere business. Who knows most about our business in Tampere? So we have a bubble and we have a knowledge. So the first would be Riku, because he used to managing our Tampere site, and now he's managing our Finland, or Osmo Hapaniemi, who is currently our site head in the Tampere. So this is another teeny tiny example where a simple approach to liberating data internally, doing the very short steps of training, applying classification, and using it in our day-to-day life as a business. And concluding, the important message is also you don't have to be a data scientist in order. Today we are living in a very unique moment where your technical team, your development team, they can actually start using those almost like a building blocks. And I would like to give you the 3 examples. Example number 1 is actually Apple. It's a Microsoft conference. Sanna, I'm talking about Apple here. So, do you have data scientists in your team? Like, who have data scientists in your organization? Ask them about the Apple Core ML. So, what we have today and already for several years is ability to have a trainable systems on a hardware completely and totally offline, and it's a part of just a regular developer package offering. So you don't really have to even know anything about that. And now we have a special tool called CreateML for more than almost a year, where you as just a developer, you can run the visual training tool, and you can choose the model, you can drag the folder with the images you would like to train. So in this specific example, the system detected that there are 12 different classes of images, and it can produce the model. And I don't know if you can see, it's actually scary. So we are talking about like almost 700 full resolution images, and in the end, the trained model is only 180 kilobytes. Kilobytes. It means that we can run it here, we can run it on the smartphone, etc., etc., etc. And we do have today crazy capabilities which are available at the hands of developers, and this is something like just like a take and use it. Windows ML, WinML from Microsoft, where if you do have pre-trained model, and the beauty of this approach is also like once you train the model, you can drop it somewhere else. You can use it with the full-blown Windows machine hardware acceleration with the DirectX. If you have a very powerful GPU, you can use it there. Or you can take it as the container and start experimenting with your data science or with the machine learning solution. Or if you are living in the cloud with I don't know if you heard ever about Azure ML Studio, which is being retired now, and now we have Azure Machine Learning Designer, where it's also a visual approach of building those data experiments and see if we can come and detect some kind of insights. So this is all, and remember, the DevOps, data, and AI if you stop considering them as the buzzwords, if you start using those slow by slow and apply to your day-to-day businesses, you can do wonderful and fantastic things. Thank you very much.